Hi, welcome to Shiko Math Practice Lab, Learning Through Practicing. And we are in the unit talk about the derivative rules and formulas. This is our practice set number 5. And in this set, we're going to talk about a very, very important rule. We call it the chain rule. Okay, so let's flip through the, what type of the problems we're going to take a look here. And so here, the first things here, we're going to talk a little bit of what is the chain rule and how to apply the formula. And then we're going to go through, and I think 9 problems. So those 9 problems, they are very, very mechanical type of the problem, just to show you how to apply the chain rule and try to find the derivative. Then the last problem is kind of application problems here, okay? And so let's go to our worksheets here. Okay, so for the worksheets here, let's go back here. Okay, so for the worksheets here, okay, so the first thing is let's talk about what is what is the chain rules here. Okay, so we talk about the chain rule is like if your function is a composite functions here. Okay, it's a composite functions here. And so we know the f of the composite function is f of g's, right? We use little o, little 0. So it's f and then the g of the x here. So the chain rule, that means if you want to take a look at if this is, I call this is a capital F here, then the chain rule will tell you the first things here, you need to take the derivative about your outer layer function. So here, then after you do that, you take the derivative of your inner layer function. So what does that mean here? Okay, so let's take a look. Let's kind of refresh our memory. So what we did so far, we said we have like the few like the formulas, right? So we call this like if y, we have the power rules, right? So it's x to the n. Then you know what is the y prime is will be the n to the x to the what? And minus 1s, right? Then we also have, we say, hey, how about we have the e to the x here. Then we say, okay, then this one here is e to the x here. Then we have our 6 trig functions, right? So the sine x, and then we said the y prime will be equal to what is cosine x, right? And the y equal to the cosine x, then the y prime will be equal to the negative sine x here, right? So like y equal to the tangent x, and then the y prime will be equal to the secant square x, right? Then you have the remaining 3. So in here, this is what the formula we learned so far. As you can see here, right? So as you can see, like every time when you look at those formulas here, right? What do they have here? They have x here, right? So it's everything is like x, y equal to the x to the n, y equal to the ex of the n's here, correct? Okay, so now, so that's what I like to highlight here. So you see here, this is x, 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 right? So it's the simple x here. So now if I have something like right now, if it's not like x to the n, so if I have x squared plus 1 to the 3rd powers here, right? So this is a kind of this is a composite functions of x cubed and x squared plus 1, right? So in here, if you change that, so you said f of x is equal to the x cubed, then the gx is equal to x squared plus 1. So this ones here will be equal to f of gx, correct? That means that you put the x squared plus 1 into the x cubed. So the keys here is every time you see something is not by x anymore, then you need to use the chain rules here. So you need to take the derivative to your out layer function, and then you take the derivative of your inner layer functions here, okay? And now let's take a look at the example. I want to show you these examples here. I remember when I was young, I was learning. I really like the one of the method my teacher showed me. I thought that was pretty cool. Is we call this M&M candy methods here, right? So you have it for the M&M candy, the outside you have what? You have like candies, right? And then you go into the chocolate part, and some of them you have the peanuts layer or you have the almonds layer, right? Okay, so like in here, so like we talk about f of x, right? So I want to find the derivative of f prime x here. So the first things you see here, right? So you see these ones here, this is a fifth power. So you say, I know, I'm probably, then like you look at the inside here, this is x4 plus 3x minus 2, right? So you say, this is kind of like so the first ones here, like, so my teacher always showed me, said, okay, so the first layer, you see this to the fifth power, right? So whatever is inside here to the fifth power, so then you can use what? You can use the power rules, right? So the power rule, so the derivative will just be the 5, and then here is 4, right? So it's whatever is inside here. Because I know how to use the power rule if it's just like the single x here. And then now, whatever is inside is x4 plus 3x squared minus 2. Then you take the derivative. What is here? This is 4x cubed plus 6x, right? And then now the final answer, what is the final answers here? You just multiply these two. So I know that then the f prime x is here will be the 5. Whatever is inside here, so this is x4 plus 3x squared minus 2 to the 4th power, then times 4x cubed plus 6x. All right, so that's why you see here, okay, so the first thing you identify, okay, so what is my basic function I need to use? So this is a power function, and whatever is inside, all right? So now let's take a look. The second one here, right? So second one, I have two functions here. So the first functions here, I see the sine, right? So I see the sine, but I know my basic function is sine x. Here is sine et. So I know my first layer, my candy part is what? Is a sine. Then here, this is my inside the chocolate part. Then the second part here, right? So the second part here, then if you take a look here, so the second part, you will see it's e to the sine t. So what do you see as sine t? So what is your basic function? It's the exponential function, correct? So since the function is exponential function, so here this is your main function, right? Then, okay, so it's disappear. Okay, here's your main function. Then what is your second function here? Is the sine t here, right? Okay, so now, if we use the ideas like, I kind of like, I really like these ones here. So we just do the first part. So my sine, whatever is inside here, right? So the sine, whatever is inside. Then the second layer, you put what? You put what is inside. So this is et. Okay, so the sine, you take the derivative is what? It's a cosine. So whatever is this function is here. Then the et, what is you take the derivative of et? Will just be et itself. So you times these two. So what is the first term you're going to become to? You're going to become to sine. So what is inside ETs, right? Sine ET times ET, correct? Okay, let's take a look at the second part here. The second part here, I know the exponential function. So this is the exponential function. So here, this is my whatever is there, right? And then my second part is what? It's a sine t here, right? So it's a sine t. Now, in here, you take the derivative will just be what? E to whatever is in here because exponentials, correct? Then the sine t, what I have a cosine t. So then you multiply these two together. So what are you going to have here? You're going to have a cosine t times what? The cosine t times e. Okay, so this is a cosine t times e to the yellow spot. So what is the yellow spot here? Is sine t, right? So you add these two. So I know this answers here. This is a sine, what is et, and the times et plus cosine, right? So t and the e sine t is here. So that means that basically you just do the derivative of the what you have for the functions, and then you can, you know, and then you can see the break it out to the layers here. Okay, so now let's take a look at these ones here. So this one, I have two functions, right? So I have x squared plus 3 plus 1 to the cube and x squared plus 2 to the 6, right? So for these functions here, so I know if I want to find the g prime x, what I need to do here, okay, so I need to use what rules here because it's a production, it's your, like your product two functions, right? So I need to use what? I need to use the product rule, correct? Okay, so the product rule is will tell me first, I hold the first one not change. So the first one not change is x squared plus 1 to the third, right? Hold the first one not change. Now let's take a look at the second ones here to see which one is my primary functions here. So this is the power. So this is my second primary. So my primary function is here. It's the powers rule. Okay, so now I can apply. So let's see, we know how to apply the powers rule. So instead of every time we do a table, so now this will be what? This is 6 x squared plus 2 to the 5th powers, right? Then take the derivative inside, so it's 2x. All right? Okay, so it's 2x, and then you plus, all right? So what you plus here, hold the second term, so it's x2 plus 2 to the 6th power, right? Still, and then you take the derivative of the. So let's take a look at these ones here. So this is inside, and so the same way the primary function is the what is the power functions, right? Okay, so now you hold the x squared plus 2, so this will be 3, right? So it's 3 to the x squared plus 1. How many left here? 2 left, right? 3 minus 1. Then don't forget you need to take the derivative of the yellow part. So this is what? It's a 2x here. All right. So let's see here. Is anything we can simplify? Yeah, we can kind of simplify a little bit. So here, let's see the common terms. We have 6. 3 times 2 is 6. We have x, and then we have the other terms here. So we can say this is 6x, right? So I have x squared plus 1 to the 2nd times x squared plus 2 to the 5th. Okay, so after that, then the first term left. What is the first term have left here is 2. It's x 5th, so I have 2 of x squared plus 1. Correct? Then plus the second term, I factor out x squared plus 2 to the 5th power. So I have what? I have still x squared plus 2, 1 power here. Okay, so now if you combine that, so the final answer will be 6x squared plus 1 to the square, x squared plus 2 to the 5th. Then here you combine the 2x squared, x squared will give you 3x squared plus 4. Okay, so you kind of combined a little bit here, okay? So now let's take a look at these ones here. So this one is the same here, right? So highlight what is your primary function. Your primary function is exponential. And I know then my secondary function is the tangents, right? That's my composite functions here, right? And now, so here, so the y prime, so you take the derivative of your primary function. So e, what is the e? Will be the self, right? So it's e to the tangent theta. Then what next you need to do? You need to take the times by the chain rules, right? You need to take a look at the derivative of your, the composite function, right? Composite functions here. So this will be what is the second square theta, right? Okay, now this one is here. Okay, number 5 is here. This one is very interesting ones here. Okay, so y equal to 5 to the negative 1 over x. My basic formula, I only have ex, right? So if I have f of x equal to ex, I know how to find derivative. We never talk about the formula if the base is not to e here. So I hope that I can find the e. So I will change like this. Let's take a look here. I know the e and the natural log, they are the inverse functions, right? So if I want here, can I put it like e to the natural log, right? Then this is the phi negative 1 over x, right? Because these two, the e and the natural log, they are the inverse function. So it will really become 1s, right? So that's why it will become the e to the, so with the phi to the negative x. So this is the trick here, right? So we need to be careful. This is the trick we need to do. Okay, now let me simplify it a little bit. Okay, so this one's here, this is e. Then I use the natural log property. I can move this 1 over x to the front, right? So the exponents property for the natural log. So it's negative 1 over x, natural log of phi. Okay, now I see here, I say, okay, finally I find my primary function is e, and then this is my, the secondary is the composite functions, right? Okay, so now let's try to do the derivative. So y prime, is what? Will just be itself, right? It's e, the primary function, natural log x, natural log phi here. Okay, so this is natural log of phi. Then I need to times the derivative of my yellow term, the secondary function. So what is that? Natural log of phi is the constant, right? So I can leave here. So negative 1, so the 1 over x is equal to x to the negative 1. So I can use the what? I can use the the power rule, right? So my negative sign is still here. So it's negative 1 times x to the negative 1 minus 1, right? So that's what is the power rule. So what is this one's here? The first term's here, right? So this term, it was just my original term, correct? So this term will just be phi to the negative 1 over x, all right? And then in here, negative is give you what? Plus, right? So negative give you plus. So now this one's here will be times the natural log of phi. Now, what happens here? This is x to the what? X to the squares here. Okay, so this one's here, then we can find a general formula. So that's why I can say the general formula here. So you might want to copy that one down for your general formula. So if f of x is equal to the ax, so the base is not e anymore. So how do you take the derivative here? So the derivative of the f prime x will just be the ax by itself. And then what? You have the natural log x here. Okay, so that's the, from this problem, we can derive this general functions here. Okay, now the number 6 is very interesting, all right? So we have several layers here. So the first one's here, you will see is a cotangent square sine theta. So what is my first layer? My first layer is here, right? It's the power rules, right? So my first layer, right? And then the second layer, what is my second layer here? My second layer after this will be the cotangent. Then my last layer is what? It's a sine theta. Okay, so this one's here, I think it will be a little bit easier if I do a picture here. Okay, so the first thing here is something square, right? Okay, so basically is what is the squares here? So let me try to write it. So it's something squares, right? So basically the first layer is cotangent sine theta, the whole thing square. So after that, you get into your second layer. So the second layer is cotangent sine theta. Then after that, you get your last layer is sine theta. Okay, so now let's take the derivative. So this is power rule, right? Because this is your primary, so it's a power rule. So this will be 2 cotangent sine theta. 2 minus 1 is 1. Then cotangent, what is cotangent? Is negative cosecant square, right? Sine theta, right? Then what is sine theta? Is cosine theta, right? Okay, now you just times. So let's see what the final answer. So the final answer will be what? So will be 2 cotangent sine theta times negative cosecant square sine theta, okay, then times cosine theta. So I think for this problems here, try to do a table is a little easier, all right? So you need to know, so right now you have 3 layers, right? So you need to do the composite functions 3 times. Okay, so now let's take a look here, right? So this one is even more interested, right? So the first layers here, let's see what is my first layers here. My first layer, okay, my first layer is a cosine, okay? So now let's try to write it. So I think you will get a better idea, use the table form. So cosine, so you have a square root of the sine tangent, right? Tangent pi x. Okay, so this is the first layer. Now, after you do the first layer, what is your second layer? See here? What is your second layer? Your second layer will be what? Will be that square roots, correct? Okay, so your second layer is that square roots, correct? Here will be this square roots here. Okay, so let's write the second layers here. The second layer is this square roots. So this square root is the sine tangent pi x, right? So square root is 1/2. Okay, after you get to the second layer, what is your third layer? The third layer is sine tangent pi x. You just break the layer, kind of we said, either some people use the peeled onions or some people use M&M example. Then after this third layer, what is the another layer? Is sine pi x, right? And now finally, I have a pi x. It's my last one. See here. Okay, now let's take a look. How do we take the derivative? Cosine is a negative sine. So it will be the negative sign, and whatever is inside. So this is the sine, right? Tangent pi x. Okay, so what is this one? Square roots is what? It's 1/2, right? So it's 1/2. This is the sine tangent pi x. Then this is negative 1/2, right? Because 1/2 minus 1 is negative 1/2. Okay, now the other ones here, sine. What is the derivative of sine? Is a cosine. Whatever you have inside here is a pi x. So what is the pi x here? Pi x is the secant square pi x here, right? And now what is the pi x here? So it's pi. You take the derivative. Now you just multiply. Okay, so my final answer, the y prime. So what is my y prime here? My y prime will be, I have here, this is 2, this is negative 1/2. So I have this ones here. I have this is the sine tangent pi x, right? And then here the top is the sine, just multiply all of them together. So this is the sine tangent pi x, then times cosine tangent pi x times the secant square pi x, then finally times pi, right? So this is what are our answers here, right? So it's kind of like, it's a little bit complicated, but it's not too bad, right? Okay, so now let's take a look at number 8 here. So number 8 here, right? So let's take a look at these square roots. So these ones here, the square roots, you can say this is x squared plus 1, x squared plus 4 to the what? To the 1/2. So what is your primary is this power rule, right? Then what is your secondary is whatever is inside here. Okay, so now let's try to take the derivative. Let me try to here. Okay, so we can separate that. Okay, so f prime. So f prime s, what you need to do, you need to use the 1/2, right? Use the power rule first. So this is x squared plus 1, s squared plus 4 to the negative 1/2, right? Okay, so you use the power rule. Then what you need to do, you need to times, right? You need to take the derivative of inside. So what the rule I'm doing the inside here, the inside is what? Inside is the quotient rules, right? So let's do the quotient rule. So this is s squared plus 4 to the square. Then you hold the bottom, s squared plus 4, then take the derivative of the 2s, s squared be 2s. Then you minus, you hold the top, right? And then take the derivative of the 2s here. Okay, that's right, okay. And now the remaining will just be what? Remaining will just be try to simplify it and try to combine it. So my first term, it will become 1/2 here. So this will be, right. So this will be 1/2. Then this is the negative 1/2, right? So that means you flip that. So it will be s squared plus 4, s squared plus 1. Then times here, this is s squared plus 4. Then you simplify here. So it's 6s minus 2s is 4. So this is it's a 2s, so this is how many s here? So this is 8s, so this is 6s here. All right, so that's it. If you want to simplify a little bit more, you can say this is 2 and 3 cancel out. Okay, so this one is not too bad. Okay, so now let's take a look at the last ones here. So the last one here, they say the tangent, so it's two function again. So for the first one, the primary is here. Second one, the primary is E. Then the second one is here, the secondary is ET, and here is tangent T. Okay, so now we know how to do the derivatives, right? So f prime T. So the first one is here, I need to take the derivative of tangent. So what is the derivative of tangent? It's the secant square, ET. Right, and then take the derivative of ET. So what is here is ET, right? ET is itself. Okay, and then plus the second one is here, the primary is E. So the E, the function, the derivative still be itself. So it's tangent T. Then you need to take the derivative to the yellow term. What is the yellow term here? It's the secant square T here. All right, so I guess it's not much I can combine. So here will just be the secant square ET times ET plus E tangent T times the secant square T. It's not much I can factor or anything. All right, that's it, right? So remember, right? So when you do this, it's pretty simple. Like for some problem, like number 7, they have many layers, then probably if you write it down layer by layer, then for each layer, you just take the derivative, like cosine becomes sine, square roots become the 1/2, then sine here become cosine, Okay, I think that will make it things a lot easier. Okay, now let's take a look at the last application problems here. So I want to find h prime once, right? So in here, the h of x here is a square roots. So this is a 4 plus 3, the f of x. Square roots is what? Is 1/2, right? So I know my primary is 1/2. Right, so then my secondary is 4 plus 3 fx. Okay, so the first layer is 1/2. So I use the power rule. So this will be 1/2. Then this is a 4 plus 3, the f of x to what? Negative 1/2, right? Because 1/2 minus 1 is negative 1/2. Now I need to times the secondary. So 4 plus 3 f of x, 4 is a constant. So when you take derivative, it's 0. So this is a 3 f prime x, all right? Then they want to find h1, so you just add it. So this is 1/2. This is 4 plus 3 f1 to the negative 1/2, and the times 3, the f prime 1. All right, so this is 1/2. 4 plus 3, what is f1? It's 7. So 3 times 7, 21. So this is 25 to the negative 1/2 times 3 times f prime 1 is 4, right? So it's 12 here. Okay, so the answers here, this will be 2 times 5, and this is 12. Then you can cancel, simplify this a little bit. So it's 6/5. So my final answer is 6/5. Okay. All right, so that's it, right? So when you see the chain rules here, remember everything deviates from the x, because our basic formula is sine x, cosine x, tangent x, or ex, x to the n. Anything deviate from that, then you need to peel that out. You say, what is my first layer basic function? What is my second layer basic function? What is my third layer? Till you peel all the onion layers till the final, you only get an x layer. All right, okay, that's it. This is the chain rule, and I cannot emphasize more how important is the chain rule. So make sure you practice all these problems and make sure you know where to apply the chain rules, right? So remember, everything is deviated from the x. Then you need to know which one is the first layer, and you take derivative, then take derivative, second layer, and then multiply all of them together. All right, and that's it. And it's very nice to talk to you about the chain rule. And then we have one last formula will be in our next video. That will be how to find the derivative for the logarithm functions here. All right, and then after that we finish this unit. Then we'll be able to jump to the next unit and do some application type of the problem. Okay, that's it. It's nice to talk to you, and you have a good day. And I'm looking forward to talk to you for our last video for this unit. All right, bye-bye.